Have you ever looked up at the night sky and wondered what lies beyond the stars? Perhaps there's infinity out there. But what if I told you that the universe is not only expanding, but it's doing so at an accelerating rate? Today we'll explore what this means for our understanding of the cosmos and why this discovery has become one of science's greatest mysteries. History of the Big Bang. 13.8 billion years ago, the Big Bang happened. It was the starting point of everything: matter, energy, space, and time. But what happened afterward? At first, space expanded rapidly, like a huge fireball. Then the process began to slow down due to gravity. Imagine that space-time is a rubber carpet. It spreads out rapidly at the beginning, but then heavy masses like gravitational pits begin to stretch it more slowly. Already a few 100,000 years after the Big Bang, stars and galaxies began to form in space, obeying the laws of gravity. What did scientists know before 1998? Until the late 20th century, most scientists believed that gravity gradually slowed the expansion of the universe. Some even speculated that the expansion would one day stop and begin a reverse process, a contraction that could lead to the so-called Great Collapse. The galaxies seemed to be evenly distributed, and gravitational force played a major role in shaping the structure of the cosmos. This was logical. The more mass, the stronger its gravitational influence. Example: imagine you are throwing a ball upward. The higher it goes, the slower it moves until gravity brings it back up. A coup in cosmology, 1998. But in the late 1990s, astronomers studying supernovae stars noticed something surprising. These Type Ia supernovae, which are used as standard candles to measure distances, indicated that distant galaxies were not slowing down, but instead were speeding up. Details: how the measurements were made. Type Ia supernovae are the brightest flares that occur when a star reaches a certain mass and explodes. These flares allow scientists to measure distances to galaxies. Why it was unexpected. The accelerating expansion of the universe was contrary to all expectations. What could have caused such a phenomenon? Dark energy, a mysterious force. To explain the acceleration, scientists had to assume the existence of something no one had ever seen before: dark energy. Einstein's cosmological constant. Einstein once introduced into his equations a factor he called the cosmological constant. It was the vacuum energy that could compensate for gravitational attraction. Although Einstein himself later called it his mistake, 20th century discoveries showed that he may have been right. The quintessence hypothesis. Some scientists believe that dark energy may not be a constant, but a dynamic force that changes over time. Interesting fact: dark energy is 70% of the energy of the universe. We can see its influence, but we can't understand its nature. It's like an invisible engine that pushes space forward. How do we see expansion? Have you ever noticed how fast the cars on the highway move if you are standing off to the side? The farther away a car is, the slower it seems, even though its speed remains the same. Galaxies behave the opposite way. The farther away they are, the faster they move away. The Hubble effect. How spectral analysis reveals galaxy removal. The relationship between the rate of removal and distance. The future of the universe. What does the future hold? If the expansion continues, galaxies will move so far away that the sky will be black, devoid of stars. We will find ourselves in an isolated part of space with nothing but our own Milky Way visible. The Big Rip. Dark energy could intensify to the point where it begins to tear apart stars, planets, and even atoms. Permanent expansion. If dark energy remains unchanged, the universe will become cold and empty. Dark energy remains one of the great mysteries of science. What is this force? How does it work? And will humanity ever be able to unlock its mystery? Oh, you believe we will find the answer? Write your opinion in the comments. If you're interested in learning more about the mysteries of the universe, give us a like, subscribe, and press the bell.